Okay, let's have a look at the Unified Physics Specimen paper. We'll call it 2016 for the spreadsheet. It's a bit of a tricky paper, to be fair. Question 1 is about a shower. This question is about the operation of an electrically powered shower designed by an electrical firm. Water moves at a constant speed through the pipe of cross-sectional area. Okay, so this bit here is going to be an area. To a shower head in figure 1.1, the maximum mass of water which flows per second is 0.070. So that's the mass of water flowing per second, mass per unit time. Show that the maximum speed of the water, so V equals question mark is the name of this game, and it gives us the density of the water as well, so that's rho. So considering when I start here, I'm going to think of density as being mass divided by volume. And when I think of the water coming out of this shower head, it's going to be coming out in a sort of cylindrical fashion with capital A as the cross-sectional area. This length of the cylinder is going to, I've done this sort of thing many times with airplanes and the like, where this length is going to be turned into a velocity. And the volume of that cylinder is going to be the area times its length. So let's start by substituting that in. That's going to be mass divided by area times length. Now if I rearrange to make length the subject, length would be mass divided by density times area. And I've written it with a little space here because what I like to do is I like to divide both sides by t. That means I've got a length divided by a time, which is a velocity, and also here I've got this mass divided by time bit, which is the 0.070 kilograms per second I've been given in the question. So now all I need to do is take that 0.070 and divide it by the density and the area. So that's going to be 1000 times 7.5 times 10 to the minus 5, and on the old calculator 0.07 divided by open brackets 1000 times by 7.5 exp to the minus 5 close brackets equals, and I've got 0.933 recurring. That's going to be meters seconds to the minus 1 and roughly equal to 0.9 meters seconds to the minus 1. Which is what the question was asking for. Only 2 marks. The next part of the question, the cross-sectional area of the holes in the shower is 1/4. Okay, so I'm given, this is a prompt for me to start thinking instead of equations, more in terms of proportionality relationships. So the holes in the shower head reduces the area to 1/4 that of the pipe. Calculate the maximum speed of the water that leaves the shower head. Well, from the equation that I've already determined for the velocity, V equals m over t density area. If I remove everything except for velocity and area, I've got V proportional to 1 over area, and if the area is being reduced to 1/4 of its original value, that's 0.25, then 1 over 0.5 is going to be 4, so the velocity is going to be increased to 4 times its original value. So the answer here is just going to be 4 times. I'll use the extra sig fig option here, 0.933, and that equals, so my answer times by 4, I get 3.733, etc. meters seconds to the minus 1. So for this I'll just record that to 2 sig figs. Good manners, 3.7, as the numbers I've been given in the question are largely to 2 significant figures. Part 3. Calculate the magnitude of the force caused by the accelerating water on the shower head. Okay, this is Newton's second law, is the force experienced equals rate of change of momentum, dmv over dt. I've got that m over t bit happening again, so this is going to be that mass divided by time bit is like a constant I'm going to bring out of the front, and then the bit that I'm interested in is the change in the velocity. So what I've got is that m divided by t bit is the 0.070 kilograms per second from right up here. 0.070 times by, and then I'm going to have to do the change in the velocity. So the velocity has gone up to a speed of 3.7 from a speed of 0.9. I'll operate on extra sig figs and round later, so 3.733 minus 0.933, which was the original velocity, and then plug that into my calculator. 0.070 times by, open brackets, 3.733 minus 0.933 close bracket equals, and I've got an answer of 0.196 newtons, and then I'll have to round that to 2 sig figs, so my answer is actually going to be 0.20 newtons. Last little bit down the bottom here, you might miss it if you're going too quickly. Draw on the diagram, draw on figure 1.1 the direction of the force talked about in part 3. So it's calculate the magnitude of the force caused by the accelerating water on the shower head. So on the shower head, I'd have to draw the start of my arrow acting on the shower head, and then showing the direction that the force will be acting on the shower head there. Page number 2, we have a continuation of question number 1, part B. The water enters the head of the temperature. Oh, okay, I see where we're going here. So this could be temperature number 1 at the maximum flow rate of, so that's our mass divided by time bit, kilograms per second, 0.070 kilograms per second, and the water leaves at a temperature, so this is our T2, temperature 2. Calculate the rate at which energy is transferred. Now the rate at which energy is transferred is also known as power, so it wants power equals question mark. That is the point of the question. Give a suitable unit for your answer. Well, I know that power is measured in watts, so I might as well put that in right now. So let's start with power equals energy divided by time. The energy in question is going to be a thermal energy, mc delta theta, change in temperature. So if I pop that into this equation, mc delta theta divided by time, I've put the divided by time here on purpose, because this is our mass divided by time, our mass per second, our 0.070 up here. So plugging in the numbers, I'm going to be putting in 0.070 to represent that entire bit there, times the specific heat capacity of water, 4,200, times by the temperature change, 30 minus 14, close brackets. On the old calculator, 0.070 times 4,200 times by, open brackets, 30 minus 14, close brackets equals, and I've got 4,704 watts, but as all the numbers that have been given to me are in 2 sig figs, I need to record that to 2 sig figs as well, so my final answer is going to be 4,700 watts. And that's question 1 done.